Hi everyone, I'm Dinsha Vinod and I'm a postdoctoral research fellow at University of Agder, Norway. So here I would like to give a brief 3-minute video presentation regarding my recent work submitted to 51st Annual Conference of IECON. Before moving on to my presentation, I would like to thank IEEE and IES for giving me this great opportunity to be a part of IECON. And moving on to my presentation on the title Adaptive Event Triggered Control for Resource-Based Autoscaling of an Uncertain Distributed Fog Computing Platform. In this work, we actually attempt an object detection problem using a mobile robot. For that, we use a Tiago robot with different cameras and sensors attached to it. With the help of these sensors, the mobile robot navigates across the warehouse kind of application environment, and when it navigates with the help of cameras, it captures the images over there. And from this vision data, the mobile robot performs the object detection. And in most of the literature, this work is done on the onboard controller. But the problem here is, if you're doing the entire navigation and detection onboard, the time to process the image will be very high. And this inspired us to deploy a distributed fog computing platform. That is, instead of doing the entire detection on board, we are sending the images to a load balancer and from there to a distributed fog computing platform. The computing platform includes several computing nodes, with each node hosting a deep learning based algorithm for detection. So here, the detection is not happening on board but in each of the fog nodes. In short, the single onboard controller has a problem of high processing time, and this inspired us to deploy a distributed fog computing platform. And for this distributed fog computing platform, we use a control theoretic approach which includes the polytopic LPV model and a control design to minimize the time to process the image. But the problem here is, in the case of a distributed computing platform, where several devices use the same network, there will be always a question of resource constraints. So to save the resources, we are using an resource constraint controller such as an adaptive event triggered control. So this controller, along with minimizing the service time, it can also reduce the frequency of control update even with the time varying parameters. And these are the control validation result. So as you can see in the figure, the time to process the image, that is the service time, is well below the threshold value by efficiently autoscaling the fog computing nodes. And these are the object detection results, which shows the accuracy of the detected items. And for that, we use SST-based object detection model. And finally, I would like to thank Research Council of Norway for funding this project. And I would like to thank IEEE IES for the travel assistance and for all the support. Thank you.